So for this video, what we're going to look at is we're going to look at a hypothesis test for proportions again, and this time we're going to look at it from the perspective of a p-value method. Okay, so we're going to go over some really key concepts when it comes to the p-value method and help you to think about how do we make the decision of whether or not we're going to reject or fail to reject the null hypothesis. So number one says, according to the U.S. Census Bureau, the proportion of U.S. women on aid to families with dependent children is 0.106. You want to test if a local community has a higher proportion of women on AFDC than the national average with a significance of 0.05. You collect a simple random sample of 400 women and find that 56 of them were on AFDC. Using technology, you get the following printout. So here we've got this printout right here. And what I want to do is I want to use the information inside of the printout in order to answer my question. So the first thing that I need to do is I need to develop what exactly is my null hypothesis. Because remember, that's going to be the thing that we decide whether or not we're going to reject it or fail to reject. So if we look here, the U.S. Census Bureau, right, our group says the proportion of U.S. women, so that's everybody, on AFDC is 0.106. So that's going to be my null hypothesis, okay? And if you look at, so I'm going to write that down. Now, by the way, in our printout, we actually wrote it there because you need it in order to utilize the technology to do the test. So P, right, is equal to 0.106. That's my null, H naught. Then my HA is going to be P, okay, let's see. Well, you want to test if a local community has a higher proportion of women on AFDC. Okay, so consequently, that's P, right, is greater than 0.106. All right, cool. Now notice it's P, so it's a one proportion test, right, equal to a parameter or P greater than a parameter. It's kind of like how we know which test we're going to be running. So hence, that's why we ended up with this one sample proportion test that we ran. Okay. Now, the next thing is we're going to be using the p-value method. So what I want to do, I want to think about, okay, I've got this big thing. If p is less than alpha, reject the null. So I look, and inside of my problem, it says that my significance level is 0.05. There we go. So alpha equals 0.05, and then my p-value is 0.0136. P, in fact, is less than alpha, right? So that is true, so we're going to reject the null. Okay, so we're going to reject the null. Now, what does that mean? That means this. There is sufficient evidence to reject the claim. And then what we want to see is, what are we rejecting? We're going to reject the null. So we're going to reject the claim of 0.106. Reject the claim that the proportion of women on AFDC is 0.106. There it is. That's what we're rejecting. Now, because we rejected it and we have a directional alternative, we should state that there is evidence to support the claim that the proportion of women on AFDC is greater than 0.106. So that's another piece of information that we actually have that's true. Because we rejected the null, rejected that it actually equals 0.106, and we had an alternative that it was going to be greater than, we do have evidence to support that that proportion is actually greater than 0.106. So that's it. We're done. This is exactly what the claim states. We compared P to alpha. We figured out what alpha was. We figured out what P was. We compared the two. P was less than alpha, so we rejected the null. There it is. Now let's talk a little bit about what that means, right, from the perspective of the concept that we're dealing with here. So now we're done with what's happening. Now I just want to kind of understand the math just a little bit, so I'm going to go into that for just a second. So I've generated my distribution, and this one has p equals 0.106 at the middle. That's my null hypothesis, right? That's h naught. There's that at the middle. My critical region is the size 0.05. That's how big the critical region is. Okay? So minimally, what I have to have is I have to have my actual statistic, my actual proportion has to be less than that, right? It has to be less than 0.05, that probability. So I'm going to generate another distribution in order to kind of see what that looks like. So here's my distribution, except with my actual test data in it. Okay? So P equals 0.106. And I go up here and I'm going to look, my sample proportion is 0.14, and it has a z-stat of 2.209. Okay? Don't need this actually to run the test right now, but to help us understand the test, we want it. So I'm going to say, okay, well, this thing here, we have this critical value. It was a z alpha, all right? Okay. Or actually, excuse me, that's not what I want. Wrong method. When I put, here's my z equals to 2.209. That's my test statistic, all right? And the area that's covered here, okay, is 0.0136. So it has an area of 0.0136, okay? Since the area, so the areas here of these two, they are the probabilities of getting particular values. So since the probability, right, P, of getting a Z greater than 2.209 is less than 0.05, this means we reject the null hypothesis. Basically, what it's saying is that the region that we get, okay, utilizing our test statistic, is smaller than this critical region, okay? And so hence, it's rarer than this threshold that we need in order to say that it is sufficiently rare to say that 0.106 is wrong, okay? So basically, the idea here is that this area here that we get with our test statistic is smaller than our region, okay? So here's alpha and here's P, okay? Since P is smaller than alpha, we reject the null. Okay. From the perspective of using technology to make our claims, what we're going to do is we're going to look at this and we're going to say, well, I get a p-value 0.0136. I'm told my significance level 0.05, and I use this simple rule. If p is less than alpha, I reject the null. There it is. Then it's all a matter of figuring out what exactly that you're rejecting and what are you supporting, all right, in order to tell us the conclusion to our test. That's all about reading and setting up your test properly. Okay? All right. I hope that helps.